Welcome to SATdecoded.com. In this video, I want to talk about solving absolute value inequalities. This is very similar to my previous video in which I discussed solving absolute value equations, but instead of an equal signs, we're going to be dealing with inequalities, which are less than and a greater than signs. The process is very similar. We're still going to come up with two different statements that we're going to solve, but there's some slight differences that I'll go over now. So the question says the absolute value of x minus 3 is less than 7. So remember, the stuff inside the absolute value bars is never going to change. We're not going to flip the signs. We're not going to turn this negative into a plus. We're not going to really do any change. We're just going to write it exactly the way it is, except I'm not going to include the absolute value bars. Okay. The second equation, I'm still going to write x minus 3 because the stuff inside the bars does not change. What does change is I'm going to flip the sign. So right now this is a less than sign. I'm going to make it into a greater than sign instead. Another thing that needs to change is this 7. Instead of 7, I need to turn it into its opposite, so negative 7. So right now I have actually two separate statements, and I need to solve both statements together. So I'm just going to add 3. I get x is less than 10, and I'm going to add 3 right here as well. X is greater than negative 7 plus 3, which is negative 4. So right here, this is our answer. If you want to visualize that on the number line, I'm going to draw it out. So here's negative 4, 0, and 10. So it says x is greater than negative 4. So that means I'm going to have an open circle right here because it can't quite equal negative 4. If it could equal negative 4 exactly, for example, if I had a less than a greater than or equal to, then this would be a solid dot. But because they didn't have this equal sign underneath the inequality, I can't have a solid dot. So that's why I have the open circle at negative 4. And it says x is going to be bigger than the negative 4. So that's everything in this direction. And the word and means at the same time, simultaneously. So it says and x is less than 10. So another open circle at 10 because it can't quite equal to 10, but x has to be smaller than 10. So that's everything right here. Because the word and means simultaneously, both these statements have to be true at the same time. That means the part that these two statements overlap, which is right here, the part I'm tracing, between negative 4 and 10. So we can actually combine these two statements into one single neat statement. It would look like this. Negative 4 is less than x, which is less than 10. If you think about this carefully, notice that the x is less than 10 right here is identical to our first statement right here. And if you think about this statement right here, x is greater than negative 4, well, what's the equivalent of that? All I can have to do is I flip everything around. Do you see how these two are exactly the same? If I flip the negative 4 and the x around, then the sign will flip along with it. So these are two identical statements. And look at this, negative 4 is less than x. Here it is right here. So I'm able to combine both these statements into one neat statement. And this statement where you have the x in the middle of two boundaries, that's what the SAT is going to provide you in their answer choices. They'll never have something that has the word and in it. Okay? So that's how you solve things when you have the absolute value portion on the left side and you have a less than sign. But what if we have a greater than sign? Well, a greater than sign is very similar, but instead of the word and, we're going to use the word or. So I'm just going to rewrite the equation or the inequality exactly the way it is without the absolute value bars. Remember, the stuff inside the bars does not change. Then I write or. So stuff inside the bars does not change, so it's still x minus 3. What does change is I'm going to flip the sign and do the negative version of this. So negative 7. And now it's pretty much the same process. I'm going to add 3 to both sides. I get x is greater than 10, or add 3 to both sides, or x is less than negative 4. notice that the numbers here are the same, 10, -4, 10, -4. But if you look closely, now the signs are opposite. Whereas right here we have a greater than sign, over here we have a less than sign. Where we have a greater than sign right here, we have a less than sign right here. So they're opposites of each other. If you visualize this on the number line, you can see why this problem is different than this problem. So here's -4, here's 0, and let's say here's 10. So the first part says x is greater than 10. So we have an open dot or an open circle, and x can be bigger than that, so everything bigger than that is right here. Or, the word or means either this statement or this statement can be true. They don't both have to be true at the same time. Whereas the word and means these two statements have to be true simultaneously at the same time. Okay, so it says or x is less than -4. So open circle at -4, since the x can't quite equal -4, but x has to be smaller than that. So everything smaller than -4 is in this direction. You can clearly see the difference between these two graphs. Whereas this one is between, it's the middle portion. These are the two extremes. The arrows pointing in two opposite directions. Okay, so that's how you solve absolute value inequalities. And if it so happened that this had an equal sign underneath, an equal sign underneath here, all you do is you include that with all your calculations as you go everywhere. Okay, so I would just kind of do that for everything. You get the idea, hopefully. All right, so I'm going to try another series of questions. These are going to be a little bit more complicated, but they shouldn't be too bad either. So let's say we have the absolute value of -2x plus 6 is less than 10. All right, the first thing I want to do is to ensure that my absolute value portion is on the left side. This is really important because if you remember the previous two questions that we did, the less than sign led to an and, whereas the greater than sign led to an or. But imagine if I have this whole statement right here rewritten like this. 10 is greater than the absolute value of -2x plus 6. These two statements are actually identical statements because all I did was flip the 10 and the absolute value portion around, and I flipped the sign to follow it. So really nothing has changed. But if I look at the signs now it's getting confused because depending on which one I solve, it would seem like I would be doing two different processes, right? How am I supposed to know if I'm supposed to do the and or the or? Well, the way to know is just always put the absolute value portion on the left side. Okay, so I put it on the left side and I have a less than right now. So less than means I'm going to use the and. All right, so I'm going to go ahead and create two separate statements for this. So I'm going to rewrite it exactly the way it is without the absolute value bars. The stuff inside the bars does not change. And then I'm going to write I'm going to write and -2x plus 6. But now you have to remember to flip the sign and make it the negative version. So -10. Don't forget, there's always two parts right here, flipping the sign and turning it negative. So now I just solve both sides. Okay, so -6, so -2x is less than 10 minus 6 is 4. Divide both sides by -2 in order to isolate the x. So these cancel each other out. I get x. One thing you should know is that if you ever multiply or divide by a negative number, the sign right here is actually going to flip. So I have to flip the sign. And then 4 divided by -2 is -2. And I'm just going to rewrite that. I'm going to solve the second statement as well. So -6 from both sides, I get -2x is greater than -10 minus 6 is -16. Divide both sides by -2 to isolate the x. The -2's cancel each other out. But because I divided by a negative number, the sign now has to flip. So -16 divided by -2 is +8. And this is my answer right here. If you want to put that together in one neat statement, we can go ahead and do that as well. So what we get is -2 is greater than x, which is greater than 8. So here is our final answer to this question. Okay, if you want to visualize that on the number line, we have a -2 and let's say 0 and 8 right here. So it says x is greater than -2. So open circle, and it's greater than -2. So everything this way. Okay, and so at the same time, x has to be less than 8. Can't quite equal 8, so open circle at 8, but it's less than 8. So it's right here. So the graph is everything in between -2 to 8, which is basically what this neat single statement says. All right. So let's try another question. Let's say I have the absolute value of -3x plus 9 is greater than 5. Okay, this time I changed this into a greater than, so it's a little different than the last question where I had a less than sign. I still remember to put my absolute value portion on the left-hand side in order to read this sign correctly. So it's a greater than, and remember greater than means or, and less than means and. Okay, so I'm going to create two separate inequalities to solve this. So -3x plus 9 is less than 5. The first one is always exactly the way it originally was without the absolute value bars. Then, because I had a greater than sign, I'm going to write or. And the stuff inside the absolute value bars is not going to change signs. It's still exactly the way it is, but just without the bars. Now I'm going to flip the sign around, and I'm going to do the negative version, so -5. So I'll just solve both of these. -9 minus 9. -3x is going to be greater than -4 divided by -3 on both sides. These cancel out. Because I divided by a negative number, I have to flip this sign, flip that around. The negative and negative become positive, so it just becomes 4/3. Or, now let's solve the second statement. -3x is less than -5 minus 9, which is -14, divided by -3, divided by -3 on both sides. These cancel out, so I get x. Remember, I have to flip the sign because I divided it by a negative number. And of course, the negative and this negative become positive because they just cancel each other out. So right here is my answer. If you want to visualize that on the number line, we can go ahead and do that really quickly. It says, let's pretend this is 0, and let's say here's 4/3, and let's say here's 14/3. Obviously not drawn to scale. Well, it says x is less than 4/3, so here's everything less than 4/3 in this direction, or x is bigger than 14/3, so everything bigger than that is in this direction. Okay, we're not able to combine this into one neat statement, so on the SAT your answer choice is literally gonna include the word or and have two separate inequality statements. All right, so that's how you do absolute value inequalities. Now I want to show you a shortcut to solving some of the inequalities. Rather than always doing two separate statements and solving each statement individually and combining them at the end, there's actually a shortcut that I call LLL. This is a special mnemonic that helps you memorize when you're allowed to use this shortcut, because you can't use this for every single situation, but for some situations you can. So the first L stands for the left side. I mentioned this earlier. That means you want to put the absolute value portion on the left side. So let's say they give you a question that is, I don't know, 13 is greater than the absolute value of 2x plus 1. Okay, notice how the absolute value right here is not on the left side. So the first step I want to do is rewrite this so that the absolute value is on the left side. And of course, if I'm flipping the absolute value portion and the number around, the sign needs to flip with it. Okay, so these two statements are equivalent. So that was the first L, left side. The second thing stands for less than. So I want to look at the statement that has the absolute value already on the left side and check out this sign right here. Is that a less than sign or not? Well, right now this is a greater than sign, so obviously LLL is failing right now. This is a situation where you cannot do what I'm about to teach you, okay? But let's assume it did meet the requirements. So I'm gonna just kind of cheat and rewrite it and just pretend it was a less than sign, okay? So forget about this one right now. We're gonna be working on this one. So it's on the left side and there's a less than sign. So if there's a less than sign, that means we're gonna do less work. What we're doing in the last 15 minutes of this video, when we created two separate statements, that's more work, that's greater work. That's what you would do if you see a greater than sign. Greater than means greater work, do more work. But if you remember, we can actually combine the less than statements into one single neat statement at the end. Do you remember that one where we had something like where we had an x in the middle and I think it was a 10, something like that, where the x is in the middle of two boundaries? Well, that was the result of combining two statements into one statement. What if we could just combine it into this single neat statement directly from the start? Rather than doing two separate statements, why not just create that one statement from the start, right? That would be less work. So the way you do that is take this stuff inside the absolute value bars, write it out exactly the way it is. Remember, it never changes. Without the absolute value bars, of course. Then just write the statement exactly the way it is. But now you just write another inequality sign, less than sign, and then you do the negative version of this value right here, so negative 13. And now we're going to solve all three parts at the same time. So I'm going to subtract 1 from everywhere. So negative 13 minus 1 becomes negative 14, which is less than 2x, because the positive 1 and the negative 1 cancel each other out, which is less than 13 minus 1, which is 12. Now I can divide by 2 everywhere. So what I get is negative 7 is less than x, which is less than 6. Okay, so that's my single statement. Very neat. If I draw that out on the number line, it would look like this. Negative 7 all the way to 6. So everything in between, and maybe 0 is like right here. Everything in between is the graph of this statement. All right. So remember to use the LLL shortcut whenever you can. It saves you a little bit of time. It's a little faster. I think this is simpler than having two separate equations or two separate inequalities. And by doing this, you also don't really have to remember that whole thing about the less than meaning and the greater than meaning or. That's kind of hard to remember, at least in my opinion. So I really don't memorize that. I just think of LLL, make sure to put the stuff on the left side, check the sign. If it's a less than sign, I can do less work. If it's a greater than sign, then go ahead and break it up into the two separate statements, and it's exactly like we did in the earlier part of this video. All right, so that's basically it. That's how you solve absolute value inequalities. Good luck, and I'll see you in the next video.